Start again. Ladies and gentlemen, what do cosmetics, sun cream, and antibacterial socks have in common? They all contain nanoparticles. Very little is understood about these tiny particles, but man has been using them for thousands of years. The Mesopotamians, if I can pronounce that correctly, used copper nanoparticles in their pottery, and it gave their pottery a metal glaze. So what exactly are nanoparticles? Well, let's take the most boring element in the periodic table, gold. Now, gold to a chemist is not very interesting. It doesn't do anything. It doesn't react. It's boring. But if I take this gold and I cut it into smaller and smaller pieces, and I keep going down to what we call a nanometer range, something really interesting happens. The properties of gold start to change, and gold becomes more exciting. For example, its optical properties change, so it absorbs light at different wavelengths. Its reactivity also increases, so we can do reactions on the surface of the gold. And scientists are using these two properties to currently in the fight against cancer. So gold nanoparticles can be coated with molecules which recognize and stick to cancer cells. And when they stick to these cancer cells, we can use light in the near-infrared region to heat up the nanoparticles. And this kills the tumor cells. And this is much safer than radiotherapy, which uses X-rays. And it's not just gold that these exciting properties happen to. Loads of different metals have these different properties. From the silver nanoparticles in your socks, which give antibacterial properties, to titanium oxide nanoparticles in sun cream, which absorb harmful UV light. The applications of nanoparticles are enormous. And just remember that it's not the size that counts, it's what you do with it. Okay?